Okay, so this first part deals with slicer. I'm loading a CAT-CT scan. I'm going to focus in on the lungs. You go into the editor tool, and then you have several choices here. I want to work with contrasts, and I want to work with the lungs, which is tissue, so I chose tissue as my option, and I am narrowing my focus so that the lungs will be the type of contrast I'm after when I highlight them with the color tool. Then I come up and I pick the paint tool once I have the lungs highlighted. The paint tool has several functions. It has some sizing, and then I can choose where on the images to highlight. And so generally you want to move to a slide that starts the beginning of the organ in one direction and go from there. Because I chose the contrasting, I can actually be a little sloppy with my edges because the contrasting, the image processing will choose the part of the image that belongs to the lung in this case. For this video, I am skipping several of the slides. When I did this on my computer, I did the slides individually. However, that took a very long time, so I'm not showing that on this video. I went through every single slide just like you're seeing here and highlighted this lung. I was focusing on one single lung. Once I'd gotten all the slides done, I come over and I chose to make the model. And then I would actually apply this, make the model. The 3D model appears in the upper right-hand corner of the window, like so. This is a 3D image, for the most part, of one of the lungs. You can see clearly where the ribs are against the lungs. You can see the outline of the lungs if I zoom out just a little bit. From here, this 3D model is easy to manipulate so we can see all different aspects. I saved this to my directory on my computer so I can access it later. As part of the project, we had to create 2 robots and then register them to each other. For each robot, you have options of selecting joints, then typing the DH parameters, or there's the built-in Puma model that is part of MATLAB. Below, you can choose a base, XYZ yaw pitch roll, or you can check random in order to randomly create a base for the robot. You create one robot at a time. When you create the robot, the axis that the robot is shown appears, and the associated sliders appear and are active. There are sliders for every joint and the angle, and XYZ sliders for the end effector point. For the purpose of this video, I'm using 2 Puma robots for ease of model. Once 2 robots appear on the axes and their associated sliders appear, the other thing that will appear is the calculation button. Now, using the sliders, you can move these robots until their endpoints are touching. This is the basis of registration. For the purpose of this video, I'm skipping most of the motion that the robots undergo. Once you have the 2 endpoints connected visually, you can hit the record button. This records the transformation matrix for both robots and calculates a transformation matrix between the 2 robots in the lower left-hand corner. Display is the XYZ coordinate for robot A. Once you've done this, then you can move to a new point and record this new point. This must be done several times to get an appropriate transformation matrix. In the lower left-hand corner, once you have 2 points or more, a list of errors will appear. This is the error between the calculated and the actual XYZ yaw pitch roll for robot B using the transformation matrix displayed above. I skipped finding the last 4 points of this. However, you can go as high as you want and use as many points as you want. The additional functionality is the clear button. It allows you to wipe all robots that have been inputted and create new robots without worrying about variable confusion. It also empties your calculation box. This concludes assignment 3. Thank you.